This interface uses a fluid layout to mimic the dappled light of a sunlit forest canopy. This is biophilic web design, a practice that integrates the patterns of the natural world into digital interfaces to reduce digital exhaustion. But beneath that serene surface is a structural failure. For a user relying on a screen reader or someone with a visual impairment, this exact layout creates a direct barrier. There is a conflict here. The organic, flowing shapes and earthy colors that make a site feel like a natural environment often clash with the rigid, grid-based logic required for digital accessibility. To resolve this, we have to make 4 sequential adjustments: measuring contrast ratios, applying color overlays, restructuring semantic HTML, and mapping out ARIA roles. A design meant to be universally restorative fails its purpose if it excludes people based on their physical abilities. We have to engineer these spaces to work for everyone. Step 1 is fixing readability. Earthy color palettes are aesthetically pleasing, but placing standard text directly over a complex texture like tree bark or a vibrant leaf pattern makes the words disappear. This animated graph shows a contrast ratio scale mapping foreground text against a background. To meet the Web Content Accessibility Guidelines, or WCAG, your text-to-background contrast needs to hit a mathematical ratio of 4.5 to 1. Many organic colors fall below the standard. To find the exact failure points, we use a developer contrast checking tool. We isolate the foreground text element and adjust the shade, trying to push that ratio needle back into compliant territory. Often, tweaking the text color isn't enough against a busy photo. The first structural fix is inserting a semi-transparent CSS color overlay. By increasing the opacity of this flat plane sitting between the text and the image, we force the needle past the 4.5 to 1 mark. If you don't want a full screen overlay, there are alternative CSS methods. You can apply a dark text shadow behind the letters, or place the text inside a solid-colored frosted UI container. Avoid making those overlays completely opaque. If you block out the natural background entirely, the design becomes digital greenwashing, hiding the natural elements and reverting to a standard boxy layout. Maintaining visual accessibility is a matter of mathematical measurement. It cannot be determined by subjective aesthetic adjustments. Step 2 addresses navigation. Breaking away from a rigid grid to create an asymmetrical layout builds a structural wilderness that confuses assistive technologies. This diagram illustrates the problem. On the left, a sighted user intuitively follows a curved path through scattered content blocks. On the right, a screen reader relies on the code sequence. It navigates by jumping erratically, trying to force top-to-bottom logic on an unstructured design. By disabling the visual CSS formatting, the issue is obvious. We are looking at the Document Object Model, or DOM. This is the raw code structure of the page, which is currently just a disorganized stack of generic div tags. The solution is semantic HTML. This acts as an invisible skeleton that organizes the code so machines can understand the purpose of each section. We replace generic layout containers with specific structural tags. The primary content of the page gets wrapped in a main tag. Next, interactive links and menus are grouped inside nav tags. Finally, secondary floating elements that give the page its organic shape are placed inside aside tags. Total visual freedom on the front end is only possible when built upon a ruthlessly organized technical foundation on the back end. Step 3 deals with platform limitations. Many commercial visual web builders restrict developers from directly editing that raw HTML structure. When you cannot rewrite the HTML tags, you use ARIA roles as a standardized workaround. ARIA stands for Accessible Rich Internet Applications. ARIA tags manually assign semantic meaning to existing generic containers. They categorize the element for a screen reader's scanning system without altering its visual properties on the screen. The syntax is straightforward. By inserting the phrase role equals navigation inside the existing container, that block illuminates for the scanning system, defining its exact purpose. Be careful not to over-apply these tags. Using a semantic nav tag and then adding an ARIA navigation role creates a redundant loop that forces the screen reader to repeat itself. This behind-the-scenes semantic tagging acts as the invisible tether connecting an abstract design to real-world usability. Look at this side-by-side comparison of the final structure against the original inaccessible draft. On the left, thin text is lost in the texture. On the right, crisp text sits inside subtle frosted containers over the exact same background. The aesthetic remains intact. Biophilic design requires engineering digital spaces that reduce stress for all human users, turning natural patterns into functional tools for restoration. Now that your layouts are updated, run them through automated accessibility auditing tools like Google Lighthouse or Axe. These verify your compliance scores and catch technical errors that are invisible to the eye. True innovation in digital design requires prioritizing universal technical access right alongside visual restoration.